So here we are. All right, so basically it's talking about your Ferris wheel, right? What did it tell you about, like, from here to the bottom? I gave you that height, right? So I'm going to draw that in here. This is 30. Okay, what else did they tell us? The radius is 25, so that would be like right here. Is that okay? Yes, no, maybe? Cool. So, how high will he be at the top? How can we figure that out? All the way at the top. 30 plus 25, right? So that gives us what? 55. I'll write that over here. So how will he be when he is at the bottom of the wheel? How did we figure that out? Alright, so in the last part, how hot will he be when H is at the position furthest to the left or furthest to the right? So, on the sides, it's what? 30. Are we all good with that? Okay, cool. So, if we go over here, that's where we're going to find the height at all those different points. So it says find the height of each of the points labeled A through J. On the Ferris wheel. I'm not sure why it changed to a Ferris wheel, but that's okay. In the diagram below is to represent your work on the diagram, so it's apparent to others calculated it all. What were our thoughts? Did we start thinking about how we could do that? Or not really? It's okay if we didn't. What do we think? Do you want to draw it? The whole
thing
width?
is 360.
So if you do 360 divided by how many slices of the pie you have, there's 10. So 36 is your center angle.
And that makes this one
Sine?
Wait, what?
Wait, what? What did you say?
I don't know. Well, this would be 25.
Correct.
I don't know where to go from there.
Okay, so we got a lot of information right here, yeah? Did y'all catch what he was saying? He was kind of like whispering up here. But, so if you like draw a line, you can make it a triangle. We know that there's like 10 slices of the Ferris wheel, so divide 360 by 10, that gives you 36 as your interior angle there. So that's where this comes from. So then, where this side? It's your radius, right? What they already gave you. So if we wanted to know the height, we could figure out this side, add it to the 30 that we already know is right here, right? And then that would give us the height of the next point. Do you agree? So how can we find that missing side of the triangle? We don't have enough sides. We have 2 missing sides. Trig, right? What trig function? What? Okay, so what are you confused about? Why did we say ooh?
Why? No, because if the radius is 25, then wouldn't all those things be 25? It doesn't go all the way over.
But if you got an imaginary line there, it's not gonna
So do you see how like it's not all the way out here, point B, not out?
Oh, yeah.
I don't think that my explanation helped at all. Are you okay? Do you get it or no?
Yeah, I get it now. I was just
Okay.
confused, and they're being but it's fine.
So are we good with like seeing this triangle here? So then you could find that missing side. We would do sine, right? Because we have opposite and hypotenuse. So we could say sine of 36 equals x over 25. Is that okay? So when you solve, x is basically just x is 25 times sine of 36. What mode do we need to be sure that we're in your calculator before you type that in? Degree, because it's 36 degrees, right? So what did we get there? So can we say 14.7? So is the height at point B 14.7? What is it? Add 30 to that, because this point right here we already know is 30. Do you agree? So if we add 14.7 to that, we'll have 44.7 feet there. Is that okay? So before we move on, is there like a pair that would kind of go with that? What point? E? Okay, so yeah, obviously E is like directly across, kind of like across from the unit circle. You know how things flip-flop like that? So over here, we know that this point is also at what height? So then we also know F, right? It's also 30.
Isn't the ones underneath it going to be the same, but you just subtract 14?
Exactly. Does that make sense? So like if we came down instead of going up to that point, it's still an angle of 36 right here. So when we do sine again, you would get the same number, but we'll subtract from 30 instead. So you get 15.3 feet. Where else could that go? On G. Are we okay with all that? Do we have any questions right now? So how are we going to find like point C? Let's just drop another line. Yeah, I'm going to draw it over here just because it's a little less crowded, but we know that D and C are going to be like partners again, right? Okay, so I'm going to drop it from here, and this angle is now, instead of 36, 72, because we have two of those 36s in there. So it's really 72 degrees in there. This is a 90-degree angle still, and we know that your spoke here is still 25, so your hypotenuse is 25. And to find that height of X, you'd use sine again, right? So I'm going to come down here because I've run out of room. If we do sine of 72 equals what? X over 25. So what do we get for X? So is D at 23.78? What is it at? $53.78? Is that okay? Because remember we got to add to 30. So what about C? Also 53.78? How would we find H and I? 30 minus. So you get 6.22. This is going to be super hard to read. Can we see that at all? It was way worse. Mine didn't pencil. Are we okay with all that? Do you have any questions right now? Did it start to make a little bit more sense? Yeah? Okay, cool. So, I believe what we're going to do next is start graphing that. So we just found Carlos's height at different positions on the Ferris wheel using right triangles as illustrated in the following diagram. That's what we did. Your Ferris wheel's got a radius of 25. The center is 35 feet above ground. He's also been carefully timing the rotation of the wheel and has observed that the Ferris wheel makes one complete rotation counterclockwise every 20 seconds. So how high will Carlos be 2 seconds after position A on the diagram? So this is going to be a little bit different, right? So if it takes 20 seconds to go all the way around, how far would it go in just 2 seconds?
Like 1 second.
How can we figure it out? What do we think? Do 360 divided by what? All the way around, divided by how many seconds? 20. So then that tells you how far you go in 1 second. So if you want to know how far you go in 2 seconds, just times 2, right? Does that make sense? I'm dropping everything. It's 18. So So it's going 18 degrees per second. If we want to know what it's going to be after 2 seconds, how could we find that out? So we'll do 2 times 18. That's going to tell us what our degree needs to be in our triangle. So what do we get? 36 degrees in our triangle. What do we do from there? Add it to what? Sorry, I should move this up so I can see where I'm writing. I get caught on other things. Didn't we already find this? So at 36 degrees, how did we get there? What did we do? Where did this number come from? So 25 sine of 36? And then what did we have to do to get here? So could we say 25 times sine of 36 plus 30? Right? That's what we did. And what did we end up getting? So are we okay with that? So could we kind of like come up with a formula to find any of them? Or to find our height at like any second? What do we think? What changes each time? Your degree will change, right? Sometimes we had to like minus with your 30 instead of add to 30, so that's going to be a little bit different. And maybe we'll get there after we do the table. So this is a whole lot. And I think it's a little bit extra, but that's okay. So basically, we're just going to go through this table and find the height at every second throughout the rotation. Does that make sense? So like at 2 seconds, we already found that. So we can write in what we did there. We did 30 plus 25 times sine of 36. And we got 44.70 feet. Are we okay with all that? So how would we find it at 1 second? Instead of our angle being 36, it'd be what? 18, right? That's the only thing that would change. Do you agree? And we get 37.73. Are y'all okay if I just tell you what we get from this calculation? Yes. Okay. So then how would we find it at 3 seconds? Add 18 degrees, right? So 36 plus 18, what do we get? 54, so 25 sine of 54. Now we don't have to worry about this second column, this reference angle, until we get an angle over 90. And we'll talk about that in just a moment. From this one, we get 50.23. For 4 seconds, how would we find that? Add 18 again, so you get 72. And then at 5 seconds, what would that be? 90? But we already know what that is, right? What was his height at 90? So it was straight up. 55. That was at the top of the Ferris wheel, right? So, to get 6 seconds, what would you do? Or what angle would we need to use? 108. Sine of 108. Our reference angle. This is where it starts to change a little bit. I'm trying to think how to explain this. So, we want to subtract 90 from that because just like we did over here, your reference angle was this, not all the way here. Does that make sense? Did y'all kind of get what I'm saying? So when we did this triangle right here, we used this angle instead of this angle, right? So this is the 108, but we don't want to use that. We use this one instead. So that's what the reference angle is talking about. So it's 72 that we use there. Does that make any sense? I don't know if it does or not, but that's what it is. So 30 plus sine of 72. So we already found that right up here, so it's going to be the same height again. Why is that okay? Because it's a circle, right? You're going to go up, you're going to come back. Yeah, so all these numbers are eventually going to end up doing what? Right? It's a continuous loop over and over and over and over. Yeah. That's that. Is it okay if I just fill in the blanks through 10 seconds? Yeah, 10 seconds is going to be halfway around the circle, right? So that's going to be at your other, like, we went here, we ended here. So your other middle point. Okay, what's up? Oh, it does. I just forgot to write it. I'm sorry. It does matter. We got to keep that in there. Ah, sorry, that was really squished. 130. So I don't know if you noticed, but the table skipped 7. So that's why that's funky. And it skips 21 later. And 35. It skips some weird things. So, and 16. Strange stuff's happening there. Plus the 25 matters. Sine of 36. To get your reference angle, I didn't tell you how to do this. You would do 180 minus this number, and that's what you get here. Does that make sense? Yeah, so that's where that's coming from. I forgot to mention that a second ago. 162. So are we good up to the 10-second mark? What's going to happen after that? We'll have to do what? We're subtracting 30 instead of adding 30. Does that make any sense? Because we're going like below the halfway or that middle point now. So that's all that's going to change. So instead of like 30 plus that number, it's going to be 30 minus that number. I don't want us to run out of time. Can we just do like a couple through there?
Yes.
Okay, because y'all have done this before, right?
Yeah.
Do we need to keep doing any of it?
No.
All right, because I want to make sure that we get all this. So what do we know how to do? Okay, we need to get an equation to like model this for any situation, or like at any angle. So examine your calculations to find the height of the rider during the first 5 seconds after passing point A. During this time, the angle of rotation is somewhere between 0 and 90. Write a general formula for finding the height of the rider during this time interval. So your height is going to be what? Do we have any ideas? Any guesses?
It's gonna be kind of like the angle of rotation.
Kinda. What did we do every time? Or what was it like in every box that we did? Sine of some angle, theta. That okay? How did we get the angle measure? 360 divided by 10?
Yeah. And that was for each thing.
That was for the first one. Once we found out it took 20 seconds to go all the way around. How did we get our angle measure? Divided by 20, right? So it was 18 times however many seconds. So we're going to, instead of theta, we'll put h equals 30 plus 25 sine 18t. Is that okay? So to break that down just a little bit, h is your height. Obviously, I'm not going to write that. 30 is midline. Does that sound familiar?
Yes.
L-I-N-E. 25 was our radius. Do we know what that means and what that curve goes with in like trig graph terms? Do you remember what that's called? Yes, no, maybe. What is like the radius? If you're talking about like a trig graph, what would that be called? How like that height up? Do you remember what it's called? Starts with the A. Amplitude? Oh yeah. All right, so we're gonna do a very rough sketch of this graph. So your midline, that's like the middle of your sine or cosine graph or whatever function, right? So ours was at 30. So if we go graph that down here, I like to put like a dotted line through 30 so I know where everything's happening around. Does that make sense? So I don't know how y'all done it before, but that's what I'm gonna do. Here is 30. So it starts at 30 degrees at 0 seconds, right? And then when did it reach the top of the Ferris wheel? At what time? Look back in our table. I think we did fill that in, right?
5 seconds.
At 5 seconds? So at 5 seconds, we reached our max height of 55. Yeah? So then when did it come back to the midline, or the middle? 10 seconds. And we didn't fill this in, but if you had to guess, how long do you think it would take to get to the bottom of the wheel? 15 seconds. Are we seeing a pattern here? And at 20 seconds, what's it going to be? Midline at 25. It'll be up at 55. At 30, mine's getting wonky. 35 would be at 5. 40 would be at your midline again. 45 is up. 50 would be at your midline again. It just repeats, right? You just ride the Ferris wheel over and over and over and over. My graph is not cute, but that's okay. So we went through that very quickly, but basically when you're graphing your trig functions, you can split it up into 4 key points. Did y'all do that before?
Yes.
And it's those midlines, the high and the low. So take whatever your period is, so how long it takes to complete a full cycle, divide it by 4, and that's the numbers that you'll put like on your line. This is all familiar? Wonderful. This is going to be super, super easy this week. I don't know. I'm not going to go through anything else. Are we okay with that? All right. So, how would your graphs change if the radius of the wheel was larger or smaller? What's going to change? What gets shorter? What did we say that this was called? Your amplitude. So if the height of the center of the wheel was greater or smaller, what would change on our graph? Your midline. What if the wheel rotates faster or slower? Your frequency. So remember that's like how wavy it is? So if it's like ding, 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 or if it's like, right? So that's going to change your frequency. So how is the equation of the height going to change if the radius is larger or smaller? What part would change? What's that number in front of something called? Your coefficient. About your A value. Have we used all that before? Yeah, okay, so that's your A value. The height of the center of the wheel was greater or smaller, what would that change? Or what? This was the center of the wheel, right?
It would change the midline.
It would change the midline. I'm gonna say the constant of your function. Do we know what variable, what letter we use for that? It's D. I just didn't know if we knew that like general formula. We'll talk about that later. So it changes your constant, which we call D. Did I say that? I don't know if I did. If the wheel rotates faster or slower, that would be like our 18, right? So how did I say it? Your degree of rotation per second. I don't know how do we want to write that. Write that in your own words. Whatever you want to say there is fine. Okay, so at the bottom there, we're going to write equations based on different situations. So it says the radius of the wheel is 30, the center of the wheel is 45 feet above the ground, and the angular speed of the wheel is 15 degrees per second counterclockwise. So they give you everything you need to know there. We'll have H equals, that constant comes first, and that's the center of your wheel, which is what this time? 45. Plus 30 sine, because 30 is your radius this time. And then every second it goes how far? So we'll have 15t. Is that okay? All right, so then the next one, since the radius of the wheel is 50 feet, the center of the wheel is at ground level, so you spend half your time below ground. That'd be super cool. And the wheel makes one revolution clockwise every 15 seconds. So since it's at ground level, we'd have like 0, right? Because it's spinning counterclockwise, we gotta throw a negative out front. Your radius is 50, so that goes in front of sine. And it goes how far every second? 15 again? So 15t. Oh, wait. Oh, JK, we did that backwards. I lied. I read that wrong. It makes one revolution every 15 seconds. So how would we figure out how many degrees it goes? Divided by 15? 24. So I'm going to rewrite this. Are we okay with all that? I think that's it on the notes, right? Yeah, that's it. Okay, so I've also got like your